Well, hello, good people. What you're watching is a presentation I gave at the 2021 Spotify Internal Dev Conference. I've just re-recorded some of the scenes, like this one, to make it more applicable to a general audience. Let me start off with explaining who I am, and a little later we'll get to how it relates to today's presentation. My name is Eric Critchlow. I started programming as a hobby in my teens in the mid-'80s and started my career as a professional programmer in 1995, right after graduating college with a degree in psychology. You see, I didn't want a career in programming to spoil my favorite hobby. But when I graduated with a degree in a field that required a master's or doctorate in order to really get anywhere, and an opportunity to take a job as a professional programmer presented itself at almost exactly the same moment, I made the wise choice to turn my hobby into a career. And thankfully, my fears never came true. Programming is still my favorite hobby. I started, professionally, in developing software for embedded systems, but soon transitioned to writing desktop software for a living. From 2002 till 2008, I was primarily writing software for Mac OS X. Then one day I got a call from a recruiter. He told me that American Express was looking to hire a team to develop for the iPhone. And since there weren't many people experienced in developing for that platform at the time, my experience as a Mac OS X programmer made me an ideal candidate. I had begun to see the writing on the wall by that point, a little later than a lot of the other Mac OS X programmers I knew, so I took the opportunity. I've been primarily a mobile developer ever since. In about 2012, I learned Android development. And ever since then, wherever I've gone, I've either been the iOS dev, or the Android dev, or the mobile dev, and at times, a member of the mobile team. Keeping up with all of the bleeding-edge APIs, frameworks, and design methodologies of development on one platform is practically impossible, even more so for both platforms. So, given my background, I lean more towards the iOS side. In my now almost 13 years in mobile development, I've worked on a lot of projects for a lot of companies, as a direct hire, consultant, and contractor. Big companies like American Express, Xerox, Microsoft, HP, and General Motors, and a bunch of medium, small, and startup companies you may or may not have heard of. Currently, I'm the Director of Development for an early-stage local startup here in Phoenix, where I'm lucky enough to not only control the direction of all of our software, but I still get to write iOS, Android, and now back-end PHP code as well. I ended up speaking to the Spotify conference primarily because, a couple of years ago, I created an iOS development video tutorial series for a company named Clean Coders, who are big on helping programmers, usually back-end and web developers, write better, cleaner code. I was asked to speak at that conference about mobile software quality, and specifically metrics for judging results. On the one hand, I was intrigued, but on the other hand, I was concerned. In my experience, quality metrics hasn't been an area of big focus in the mobile world, so I didn't think there would be enough material to do a full talk on. So we expanded the focus of the talk a bit to cover mobile software quality in general, with part of that devoted to quality metrics. Now, for this extended focus, the subject of writing quality code is a huge area for which bunches of big, thick books have been written. So we're going to focus on 3 specific areas that I think are tremendously important: architecture, testing, and problem resolution. So let's kick it off with architecture. Before getting into issues specific to mobile, I want to talk about some more general issues related to software development. There are some well-established industry standards, or at least supposed standards, when it comes to software architecture. But much of this is targeted at fields of development that aren't mobile or even desktop applications. For those of you with some experience in other programming arenas, you may well have heard of SOLID. SOLID is a set of software design principles developed a couple of decades ago that a lot of software engineers swear by to this day. Many consider them to be de facto best practices. People do whole talks on each one of these principles, so we're going to skip going into any detail here. But there are two of them that have relevance to some of the points I'll be bringing up later, so I want to spend a minute to explain those first. The S in SOLID stands for the single responsibility principle. This principle basically states that any class should have only one purpose or responsibility. I expect that most mobile developers' eyebrows should raise at that suggestion. We'll get back to it shortly. The D in SOLID stands for the dependency inversion principle. This basically states that software modules should be loosely coupled, such that high-level modules shouldn't depend on the implementation details of low-level modules. We'll get back to this after a while as well. Another industry standard I want to touch on for a minute, because it actually has some importance to being empowered to focus on quality, is Agile. At this point, most of us just assume that every programmer knows what Agile is and is probably working under one of the many forms of it that people have warped it into. I actually gained a much better understanding of what Agile was originally intended to be a couple of years ago when I read this book, Clean Agile, which happened to be written by one of the founders of the Agile movement, who also happens to be the creator of the SOLID principles and the Clean Coders company that I did the video tutorial series for. What's important from that book here for our talk today are three things. One, if quality is really going to be a priority for your organization, you have to have buy-in from management in every segment of the organization. Two, developers have to be empowered to say no. I realize most of us don't have that empowerment, or at least don't feel like we do, but without it, you will inevitably be forced to make choices that you know will sacrifice quality. At the very least, you have to be able to go on the record with the likely consequences of the decisions you're being forced to uphold. And third, you have to build in time for testing and refactoring into your estimates. I know good and well that I feel uncomfortable estimating a piece of work at anything longer than what I think it should take to write the code, assuming all goes according to plan with no major impediments. But not only does it almost never go this way, but that estimate never includes time to properly test the feature or refactor the code once the feature is working to make it as efficient, understandable, and maintainable as it could and should be. And the last general standard I want to touch on is TDD, Test-Driven Development. This one I would say gets the most pushback, as some developers are absolutely devoted to it while others roll their eyes at it. Again, I'm sure we've all heard of TDD, but we may not all know exactly what the strictest adherence to TDD means. In its purest form, TDD says that not a line of production code is written until there has been a test written that the line of production code is intended to pass. Test code always comes before production code, and tests for a given function evolve as the production code evolves until both are complete and, presumably, rock solid. Excuse the pun. At the company I worked at before starting my mobile career, one of the developers believed strongly in TDD and wrote tests for every feature he was developing before he started coding the feature itself. Our manager wasn't a fan of TDD and referred to that developer as a slow programmer and didn't regard him very highly. I'm pretty sure you don't want to be in that position. So again, if you value TDD as a method of writing quality code, you have to have buy-in from management that sees the value in it and respects the process. Okay, now how does all of this relate to mobile development? Let's start with Apple and iOS, though much of this will apply to Android as well. From the beginning, and to this day, Apple deems the primary design pattern of iOS to be MVC, Model View Controller. Long-time and maybe even short-time iOS developers will likely have heard that MVC also stands for Massive View Controller. And this is where we go back to the S in solid, the single responsibility principle. It would be a tremendous stretch to say that a view controller's single responsibility is managing the view. Views often have a variety of purposes, UI, and functionalities. On top of that, one of the foundations of the single responsibility principle is that a class should have only one reason to change. So, if you have a view controller that manages a view that is responsible for both signup and login, and your signup flow changes, your view controller subclass has to change even though the login flow remains the same. This violates the single responsibility principle. Now, I'm not here to tell you that the single responsibility principle is good, or even reasonable to apply to iOS or Android. We'll get to that in a minute. Development. But I am here to tell you that a lot of high-end developers consider it a best practice. And certainly, the more responsibilities you give a view controller, the more code it will contain, the more business logic may infiltrate it, the more bugs it's likely to contain, and the more you will violate that other principle of solid we touched on, the D, the dependency inversion principle. A view controller is a high-level module. Many a view controller has lots of dependencies on lower-level modules. So think carefully about where you draw the line between how much code you extract from your view controller into other modules and how much risk you're willing to take by leaving code in them. I insinuated earlier that the solid principles don't necessarily apply to mobile development. However, there's a contingent of iOS developers who think that solid definitely should be applied in that arena. There is no shortage of articles discussing the best ways to apply the solid principles to iOS development. And to that end, a framework has been created for iOS development called Viper. Viper is an implementation of clean architecture, which is itself a paradigm for developing applications using solid principles. Now, I don't know how prevalent Viper is in the vast world of iOS development projects. I only learned of its existence myself a year or so ago. But one rule of thumb I like to use when judging such things is to look at job postings to see what buzzwords and technologies are listed in them. I've only ever seen one, maybe two job postings that mentioned Viper. Take that for what you will. But what about Android? Are things different in that developer ecosystem? Google is a less bit strict in their pronouncements for Android development. You'll see references in the Google Android docs to various design patterns, including MVP, Model View Presenter, and MVC. But most likely you'll see them talk about MVVM, Model View View Model. But regardless of which design pattern you choose, you can still have massively big activities and fragments, same as the view controllers in iOS. And they violate the single responsibility principle just as badly, if you care about that. If you're interested in applying solid principles to Android development, much like iOS, there's no shortage of articles to help you down that path. And, wouldn't you know it, Viper has been adapted to Android as well. Now, architecture is easiest to implement at the beginning of a project. Some architects who have suffered from a paralysis by analysis might disagree with me, and I know I have personally spent an inordinate amount of time at the beginning of several projects deciding what the architecture would look like. But regardless, I stand by my statement. Nevertheless, it is most certainly not at all impossible to change architectures, or more specifically, design patterns, in an existing codebase. When I was at General Motors, 3 or so years into the life of our Android codebase, for an app with 100,000 plus users, we switched from an MVC implementation to an MVVM implementation, and it wasn't a Herculean effort to do so. So consider the codebase you currently have. Is it antiquated? Have the platform's best practices left you behind? are facilities that you originally had to roll your own version of now available as part of the standard SDK. Don't fix what isn't broken, but don't be afraid to make substantial app infrastructure changes to a code base that isn't quite broken, but aging and possibly crumbling. And there's just one more thing I want to touch on about architecture, but we'll get to that in just a minute. Now, let's move on to our second topic, testing. Testing is an interesting topic. Some developers love it, some developers hate it. Lots of developers in either camp don't really bother to talk about it. I've been in many discussions over the years with other developers where all kinds of topics in the field of development were discussed. I don't ever remember being in a single conversation where the topic of conversation was testing. Given that I've been doing this professionally for over 25 years, I'm a relatively recent convert to testing. And of course, by this I mean coded tests, unit testing. For most of my career, I was ambivalent about unit testing. Then when the TDD movement started gaining more steam, I became actively hostile to it. If any of you are old-time macOS 10 users from the early days, you may remember an alternative web browser called OmniWeb. The company that created that product, the Omni Group, was co-founded by a guy named Will Shipley. Will is a big name in the Mac development community, especially among indie Mac devs. Well, one day Will wrote this blog post, and I was like, yeah! This was my mantra for a long time. It's really only been about the last 4 years that I've warmed up to unit testing. As much as I'm aware of, and can talk competently about best practices, I don't always follow them. One place I buck those best practices is in back-end communications. I've repeatedly seen posts and articles where well-regarded mobile developers counsel other mobile developers not to write their own networking code, but to use one of the industry standard third-party libraries. But I have long held that networking code for both platforms is fairly straightforward and easy to implement, the one caveat being if you're dealing with a complex authentication scheme. Other than that, I consider it preferable to roll your own networking code. So a few years back, I did just that. In fact, I wrote my own framework and library for both iOS and Android to do networking, data persistence, object inflation, and a few other architectural facilities. I intended for this framework and library to power my personal and professional apps for years to come. Now, if you're going to buck best practices and roll your own solution, especially in your day job, your reputation, and perhaps your very job itself, are on the line if you screw it up. So I knew, without even giving it much conscious thought, that I needed to be confident that this code I was relying on for the basic infrastructure of these apps needed to be absolutely reliable. How was I going to ensure this reliability? No other way I could think of than to have complete unit test code coverage of every feature. And to my surprise, I actually enjoyed implementing those tests and took great pride in seeing the code pass them. A couple of minutes ago, I mentioned one more thing I wanted to touch on concerning architecture. A year or two after I wrote this framework and library, I was given a project at GM to write both iOS and Android versions of an app to control and track our new e-bikes. For that project, the time I spent writing this code paid dividends. It not only significantly cut down on development time, but the common API shared between both versions made the structure of both apps very similar, such that when there was a bug in one, it was often the case that the bug existed in the other, and this made bugs in business logic problems very easy to track down on one platform after it was discovered on the other. Of course, most of the time, you have two separate teams working on apps simultaneously, such that the luxury of a unified architecture is unlikely. But I would suggest that, if at all possible, developing a unified architecture with a common API leads to greater quality control in apps. And again, it's always possible to go back and retrofit an existing code base if you so choose. So, back to testing. Both Xcode and Android Studio have very good support for unit testing built in. Android uses the tried and true JUnit, which Java developers have been using for over 2 decades now. It's great for testing the logic of your Android app. Learning how it works and how tests are constructed is incredibly easy. For testing response-dependent processes like a network request, it's very easy to pause execution and check results after a determined time. It's completely sufficient for many use cases. On iOS, Apple created XCTest. For anyone familiar with JUnit, learning XCTest is almost automatic. For those who haven't been exposed to unit testing before, it's practically as easy as JUnit to learn from scratch. It has most of the same functionality, and one benefit that it has over JUnit is that it has better support for response-dependent processes. Up to this point, you might notice that I keep mentioning unit testing. And I can imagine a lot of you are thinking, but what about UI testing? Both platforms and development environments also support UI testing, including the ability to record a series of user actions to be scripted and saved as a UI test for reuse. Android through SpEC and iOS through XCUI-test. Back before there even were smartphones, UI testing of desktop applications used to be the holy grail. Now the functionality is somewhat commonplace for mobile platforms, but we still are far from holy grail status. Especially for iOS, it's not hard to find people online lamenting about XCUI-test not being very reliable. And even if that weren't the case, there are distinct differences between unit tests and UI tests that make them very different animals. We may not know every possible input a method that we're testing might get, but we know common values it will receive and probably a few potential edge cases, and we can write tests for each of those possibilities. In the end, if we're diligent, we can have pretty high confidence that our test suite exercises our method to a reasonable degree. UI tests are different. While they generally have fewer inputs, a button can only be tapped or perhaps also long pressed. UI elements don't produce a testable value as output. Activation of such elements results in processing and interaction of various modules within the application. Timing can also play a critical role. If a given view has 10 controls on it, and some of them cause processing that may not complete immediately, what happens if multiple UI elements are interacted with simultaneously? For those 10 controls, are you going to write tests that cover interacting with each of them in every possible order, with variable time in between each interaction? Certainly not. It would be a waste of valuable development time. Code coverage is a reasonable metric when referring to unit tests, but there is no reasonable equivalent for UI testing. My suggestion is that UI testing is most useful for testing the happy path, making sure that when the user behaves in a predictable way, attempting to execute a normal workflow, that no changes have broken the workflow, preventing the user from being able to accomplish the task. This is great for regression testing when changes to the UI, view controller, activity, or fragment have been made. But when it comes to catching problems before shipping an app caused by user interactions, good old-fashioned manual testing still can't be beat. And when it comes to catching problems after an app has shipped, there are some great methods for doing that we'll discuss in a bit. Since most apps are heavily focused on user interactions, it becomes difficult to understand what needs to be tested and how much effort should be put into automated testing. As I mentioned earlier, you don't often hear a group of random developers really having spontaneous conversations about testing. In my own personal experience, in over 12 years of mobile development across a bunch of projects and companies, only twice has automated testing of any kind even been a point of focus. Almost a decade ago, I worked for the consultancy and was on the team that wrote the first versions of the iOS and Android Microsoft Azure SDKs. We had 100% code coverage, but that was for an SDK. SDKs can and should generally have 100% code coverage. And at General Motors, after our app had been available publicly for a couple of years, our team stopped working as a startup within a large organization and shifted to a more traditional business unit. As part of that transition, management started setting goals for unit test code coverage. More on that shortly. Besides those two examples, I've not been on a project where any kind of automated testing was even discussed. But that's just my anecdotal experience. I was curious as to what the broader experience is across the mobile development world. Turns out, it isn't all that easy to nail down. The best thing I found was an academic paper where a couple of students queried 46 companies about their mobile testing practices. Their results, based on the responses of these companies, is that less than half of them utilize white box testing, which is synonymous with unit testing for the study's purposes. And of those that did this testing, code coverage was, on average, under 50%. For anyone interested in the full paper, reach out and I'll send you the link. Out of further curiosity, I did some polling of my own in some of my social media circles. Between LinkedIn, Twitter, and Slack, I got 40 responses. 8 do no unit testing at all. 13 have 50% code coverage or less. 8 have between 51% and 75%. And 11 have between 76% and 100% code coverage. From my experience at GM, by the time I left, the back-end code was at or near 100% code coverage. The iOS project was around the 30% range, and the Android project was at less than 15%. So how do we digest all of this and determine what levels we, as mobile development teams, should be shooting for? Well, I have a couple of ideas. The first borrows from a mantra I first heard at an Apple Worldwide Developer Conference well over a decade ago, before there was even an iPhone. But I've also heard it a number of times since then. It applies to code optimization. The mantra is, don't do premature optimization. Profile your code, find the bottlenecks, and spend your optimization efforts there. I would apply this to code coverage, in the case where you are retroactively adding unit tests to an existing code base that was written without them. Don't add tests to code that never gets touched and gets exercised enough to know that it currently works fine. Add unit tests to code that changes with some regularity or is changed recently. Use analytics to tell you what features of your app get used the most, and add unit tests to the code those features rely on. If you're writing tests for new code, and you don't have the option of writing tests for all of the processing code, focus on business rules. Those tend to change a lot. And add tests on the modules that handle incoming data. That's where a lot of bugs and crashes tend to occur. And when it comes to code coverage metrics, what number should we aim for? Unless your number is 100%, I don't really think it's a good question. If 10% of your code is only exercised 0.1% of the time, and it isn't mission critical code, then that 10% of code isn't that important to test. As I said a minute ago, analytics can help you make these determinations. And there's one more big reason that focusing on the code coverage number isn't necessarily that productive. There's something we used to do at GM when management handed down directives for code coverage percentage. This isn't that GM project, but you'll get the idea from it. We check this report on code coverage, and we see that the number is X. But what went into that number? If you looked a little deeper, you'd see that we were including sub-projects in our code coverage report. Sub-projects included the open source networking library we were using for back-end communications that just happened to have full unit test code coverage. But should that really count? This was an industry standard, heavily used and highly regarded third-party library. Tons of iOS projects relied on it, and most iOS developers knew it was completely trustworthy. And, most importantly, it wasn't our code. The test coverage of this library told us absolutely nothing of use. All it did was boost our numbers so we could report that we were closer to the goal. We did the same thing on the Android project. Stop including the coverage of third-party code, and our coverage numbers went way down. Now, it's true. As a matter of convention, you can choose not to do this. But in a pinch, when directives have been issued, when the stakes are high, when we're doing things to meet requirements and not out of the pure desire for the best code possible, things like this creep into the mix. So this is a big reason why I suggest not focusing on the number and focusing on getting the most bang for your testing buck. And this brings us to our third and final topic for today: problem resolution. If you've written perfect code for anything beyond Hello World or maybe Bubble Sort, congratulations, you're the best programmer in history. For the rest of us, we write code that has bugs. Those bugs eventually reveal themselves, and sometimes those bugs make our apps crash. Crashing isn't necessarily a bad thing, especially if there's no data loss. Better to have a crash that shows there's obviously a problem than to have a bug cause data corruption, data loss, or faulty results somewhere down the line where it's hard to detect and even harder to trace. But users don't necessarily see it that way. They can consider an app crash a sign of a terrible, unreliable app. So it makes sense for us to always focus on keeping an eye on our app's crashes and addressing them as quickly as possible. And there are a number of tools at our disposal to help us do just that. First and foremost, make use of the tools that Apple and Google give us. They can be instrumental at leading us right to the source of a crash. They also tell us how prevalent a given crash is amongst customers. Got crashes in production? Go to the organizer to see exactly where they're happening. Android developers, the Google Play Dev Console is your friend. Use it to see all of your recent crashes and the stack traces that help you track them down. Fortunately, we don't currently have any crashes to be looking into. You're probably also using a third-party crash tracker as well, and if not, why not? The more info at your fingertips, the better. But I'm sure I'm not telling you anything you don't already know here, and that's not really what I'm here to do today. So let's look at some other things we can do to address problem resolution. Earlier I talked about analytics as a way to determine what parts of our app, and thus your code, are getting exercised the most. I think a lot of us use analytics in our indie apps for all kinds of purposes. But when it comes to adding them to our day job code base, we think of the business folks asking for this or that new analytics tool to be implemented and just think of it in terms of their usage. It doesn't have to be that way. Analytics are a great tool for developers to utilize to identify the frequency of events happening in their code. You have a potential error condition that you offhandedly write some generic code to handle because you don't really think you'll actually see it in the real world? Add an analytics event to it to test out that hypothesis, and add enough info to the parameters of the event to be able to determine what unique aspect of the case caused the failure. Want to know the sequence of events that leads to a hard to reproduce bug? Leave an analytics breadcrumb trail in the user's journey to see how they got to where the problem occurred. Next, as much as you might have a tremendously high app rating that I'm sure you're quite proud of, as well you should be, don't ignore the lower ratings or complaints, or even the "it's great but" comments in your reviews. They can point you in the direction of actual bugs and not just users who disagree with your UI or design decisions. Mobile apps are unique in the places where problems are often found. The best way to fix a problem is to avoid ever having it happen in the first place. Understand the typical problem areas in mobile apps and take steps to ensure against them beyond just expecting developers to remember to be wary of them. I've written, worked with, and gotten to look at a lot of mobile code bases over the years. The vast majority, mine included, treat low memory warnings as an afterthought. Some log the warning, most do absolutely nothing. Years ago, I wrote a social media app that had an image viewer that scrolled through a series of images. It kept crashing on an old iPad. I eventually figured out that the OS was shutting the app down because of memory constraints. Now, this was back when the iPad had precious little memory. Devices today have tons more, so you might think we no longer have to pay attention to those warnings. Well, just a couple weeks ago, I started seeing memory warnings in the console of an iOS app running on modern hardware. Be aware of the memory warnings your app gives you. And if you're writing iOS apps, get familiar with instruments to help visualize what your app is doing with regards to memory usage. Another common issue. When I interview prospective mobile developers, I always ask one question. You just retrieved data from the back end, and some UI element is altered based on that data. But for some reason, the UI element isn't updating. What's the first thing you look at? Maybe my question is too vague or poorly worded, but I rarely get the answer I'm looking for, even after leading the candidate a little bit. A very common problem in mobile code bases that causes random bad behavior, from nothing noticeable to app crashes, is calling methods on UI classes off the main thread. I make the mistake myself occasionally. Usually, we expect developers to remember when they are in a situation where they need to explicitly run code on the main thread. You know the people you work with. Do you really want to rely on them always remembering that? Heck, you know you. Do you trust you to always remember that? One codebase I was exposed to implemented an architecture which caused all back-end responses, which don't happen on the main thread, to be funneled to the other app modules on the main thread. Thus, any code written to modify the UI in the code that processed back-end responses automatically ran on the main thread. Maybe that's not a difficult architecture change to make in your own code. One last common problem area I want to hit on. During the first year or two of developing the main app I worked on at GM, our Android app had not infrequent crashes. Often in QA, but even in production, a lot more frequently than we would have liked. The vast majority of the time, the source of the crash was the app code relying on back-end responses to be in a certain format, and the back-end team changed that format. Sometimes a field we expected to be non-null was actually null. Sometimes a field was taken away entirely, so the code that parsed responses blew up. Sometimes a field changed from a number to a string. And as this was early in our history, before we had unit tests which made sure such changes didn't break things, boom, we blew up a lot. At the time, I blamed the third-party libraries we used for networking and object inflation. That was one of the reasons I wrote my own infrastructure framework and library. But in reality, it was because we wrote code that made assumptions and didn't write code that was forgiving when the assumptions weren't met. Beef up your back-end processing code and add unit tests to that code. Target a high level of code coverage in that area. Okay, we've come to my favorite part. There's just one more thing I want to talk about in regards to problem resolution. Now, stay with me here. I know you're going to raise an eyebrow and probably roll your eyes when you hear what I'm about to say, but just hear me out. The most important problem resolution technology I know of is logging. Hey, I know, I warned you, but let me explain. I get it, I've seen the code. Most of us treat logging as an afterthought. Maybe we drop some debugging statements in the logs that don't get run in production code, or maybe they do. But beyond that, what's the point? I thought the same way for most of my career. Then I worked on an app that had to connect to a car via Bluetooth. that experience all kinds of non-reproducible errors in production. That's when I learned to love logging and realized just how much I could do with it. Android has pretty standard logging facilities built in. Apple introduced some really interesting logging features at WWDC 2020. But I've been doing lots of stuff with logging for years, so I wrote my own logging system. So let me talk to you for a bit about what logging can do for us. First, and this is vitally important, log everything of significance. I characterize my log entries into several levels, depending on the app. The common levels that apply to all apps are error, network communications, notifications, user action, and info. That way I can filter them by level of significance. But having all this logging info is important in trying to debug production issues. The next absolute must is to provide a mechanism for users to send their app logs in with complaints or error reports. In my apps, when the user elects to send a support email, the log file is automatically attached to it. I keep a rolling log of about 8 megs, so it's never too big to attach to an email, and it always has the most recent entries. Now, the next thing is something I've wanted to do for years, but am only now in the position to make the decision to support it. I'm adding a phone home mechanism into my apps. When we know that there is a user experiencing a problem that we need the logs to diagnose, we'll send that user's device a silent push notification. A silent push notification is one that the app receives, but that the user is never aware of. The device doesn't show the user that a push notification has been received. That silent push notification will contain instructions to tell the app to send its logs back to us the next time it is able to do so. This could also be implemented as a flag the app receives when it is active and makes a routine API call back to the backend. This way, we don't have to engage the user and rely on them to manually take steps to send their log file in. There could also be error conditions in your app that you might have trigger automatic sending home of the app logs. Oh, and if you're developing for Android and you're logging, and you're not utilizing an uncaught exception handler to log the stack traces of uncaught exceptions before your app crashes, add it now. Same if you're on iOS and you're not utilizing NSSetUncaughtExceptionHandler, though unfortunately it only works for Objective-C code. And now we get into the good stuff. For two of the biggest projects I worked on at GM, I created an encoding scheme for the logs. With this, each log statement had a human-readable component and an encoded component. Yes, adding all these logging statements and manually adding the encoding to each one is a significant undertaking, but it pays dividends. Having a log file with encoded statements, I was able to write a desktop application that could parse the logs. Of course, any text reader could view the logs, but the purpose of this application was that it could be given to first-level support personnel who usually aren't technical enough to understand raw log statements. The parser had some intelligence built in that would allow it to generate what I called a story, a human-readable account of a user journey. And if the issue was escalated to a next-level support person, each event in the story could be expanded to show the raw log events that went into interpreting that event. Again, this is a substantial undertaking, but the benefits that we can gain from it are worth considering putting in that effort. If you come away with nothing else today, give some serious thought to doing more with logging. All right, so let's take a look back at everything we covered today. First, decide what architecture works best for you and implement it. Transition from an existing architecture to a new architecture if need be. To help make this possible, design for change. I mentioned my preference for rolling my own networking code. When I started my primary Android app at GM, we inherited code from an earlier similar app that used retrofit for networking. Time limitations didn't allow me to immediately replace retrofit with a homegrown solution. So later in development, I went back and re-architected our network code so that we could seamlessly switch from one networking stack to another with a simple configuration change. Second, implement unit testing, but go about it in the smartest way possible. Work smarter, not harder. Decide where you get the most bang for your buck. In other words, add tests where they are most needed and can do the most good. And lastly, put yourself in the best possible position to handle problems. Track crashes, take steps to avoid the most common problem areas of mobile apps, and maximize the use of logging. And with that, our little adventure together comes to an end. That's all I got for you. I thoroughly enjoyed the work that went into putting this little presentation together. I hope you enjoyed it, and I hope I gave you at least a little info you didn't already know, and an idea or two about new things you could do to improve the quality of your code. If you want to get the link to the academic paper I mentioned, or have any questions or anything you want to talk with me about, you can find me on Twitter at MrEGC, or email me at eric@infusionsofgrandeur.com. Yeah, I know, it's a mouthful. Thanks for watching. It is much appreciated.